SwayamPrabha. Digital India. Educated India.
We will start this lecture with a thought process from Lord Buddha, whose image I have shown here, which happens to be a non-ferrous metal. He says that trouble is you think you have time. Today we will be basically discussing about extraction and smelting of zinc in ancient India, and I have chosen this because it is considered to be the first unravel in our country in ancient time. And so, you must be knowing that zinc is the 24th most abundant element in earth crust. As a result, zinc is one of the most common metals in use after iron, copper and aluminum. This is the fourth metal which is being used plentifully. And you might be knowing that like we use galvanized iron to avoid the rustings on it, and basically that is zinc is being coated on that. And zinc is a silvery white lustrous diamagnetic metal, and zinc is hard at the same time brittle due to its closely packed hexagonal crystal structure. If you look at the crystal structures I have shown here, this is hexagonal and it is quite packed. As a result, you will get these properties. And zinc is a volatile metal and has a low melting point around 419.5 degrees Celsius. Of course, I have written 419 just to make you to remember, and low boiling point around 907 degrees Celsius, but gets readily oxidized around 550 degrees Celsius in open air. As a result, it is very difficult to smelt as compared to iron, because of fact that the boiling point of the zinc is lower than the temperature at which it could be smelted around 1000 degrees Celsius, and when as soon as it will come in contact particularly the zinc vapor with the air, it will get oxidized, and therefore, it is very difficult to smelt as compared to the any other metal. So, most of the common zinc ores in India and others also, other places also, like zinc sulphide, what is being also known as sphalerite. Here I have shown a figure that which is basically ore and is having some structures, and where it is some zinc will be there. And of course, in this sphalerite you may find iron also in that, zinc carbonate and zinc oxide. Generally zinc oxide is not available plentifully, but however, the zinc sulphide is converted into zinc oxide and then you can get the zinc metal out of it. The ores of lead, zinc, copper, iron and silver often occur together along with the zinc. Therefore, it is one has to be very carefully handle this kind of metal. So, if you look at the applications of zinc metal in modern time, it is quite enormous. Let me just give you overall pictures, like application wise, as I told, the construction, we use the zinc, shipbuilding industries, household electrical applications, batteries, like, and then production of alloys like brass, and then other metals being used, galvanizing to protect the steel, as I had told earlier, as a chemical additives in rubber and paints, and in automobile of course, we use this plentifully. And of course, there are several other applications which I have not included here, but zinc is being used very much and it is being produced plentifully. So, let us look at now the what are the evidence of zinc being mined and smelted in ancient India. Some of these evidences we will be discussing because of due to paucity of time. And if you look at the evidence being obtained particularly from Ganeshwar Jodhpur cultural complex in North Rajasthan and Ahar culture in southern Rajasthan, and these are basically what you call people obtained from these area around 5,000 copper bronze objects, and they have carried out radiocarbon datings, and it amounts to be that these products are basically belong to second millennium BC, that is being checked. And beside this 4th century BC, people got brass vase in Taxila, which happens to be the now Rawalpindi district of Punjab in Pakistan, and which contains something around 33.4% zinc. And Mesolithic site of Beggar in Bhilwara district of Rajasthan also yielded a few copper arrowheads, and of course, it will be containing some amount of zinc. You can call it as a basically brass arrowheads. And in northern India also several circular, rectangular, punch marked and other coins of brass dating between something 200 BC to 4th century AD were found out. If you look at there is a more archaeological evidence of zinc in ancient India, it goes to the Harappan site like Lodhal, and then Kalibangan, another one site in northern Rajasthan, and they found around half a dozen copper based objects containing zinc around 3.4% is might be this copper will be having this what you call impurities zinc, whether they have added or not, that is the one question generally comes over, but their timing of manufacturing dates back to something 2200 to 1500 BC. And there is another site where people got what you call two evidences of brass, which is from early Iron Age dating back to around 1200 to 600 BC, and this site you are very much aware. This is a Antranji Khera site, which is near the river Kali Nadi banks, a tributary of Ganga in the Etawah district of Uttar Pradesh. So, as I told earlier, in Taxila large varieties of metal objects made of copper, bronze, brass, iron dating back to 400 BC to the 100 AD were found out, and excavation work carried out by British Museum and MS University of Baroda and Hindustan Zinc Limited at Jawahar, Rajasthan around 1982 provides a very conclusive proof of highly developed extractive metallurgy technology for zinc metal in ancient India. And if you look at they have also concluded that the India should be credited to the to introduce this metal to the world between 600 to 200 BC, because actually they did a very extensive study jointly and then unravel. As a result, later on this around 1988 American Society of Metals recognize these sites at Jawahar mines as one of the international historical landmarks for the zinc, right, because of this research. And I am just showing some of the things what they got during this research, that this is a ancient zinc retort distillation. They are saying this is the furnace and these are the some kind of things. And we will be discussing more about this zinc distillation method, which is being they have found out several of them, and these are the retorts which are being used for the making a house. These are the being layer by layer, they are using as a bricks in some places they found at that time, and this is near Udaipur of Rajasthan. That means a lot of production of this zinc might be going on. Let me tell you another very interesting fact which has been quoted in various literature I have taken, that is William Champion established a zinc smelting furnace in 1738 AD at Bristol in England and started commercial production around 1743. And according to this day, his furnace was quite similar to the Jawahar example with a downward distillation. And it is interesting that the Champion used exactly the same technique of distillation that was used at Jawahar, and even use 1.5% with common salt in zinc smelting charge, as mentioned in this Biswas paper. I have given the references, that is the John Day 1973, who is talking about this Bristol brass, a history of industry. And it might be happened, as claimed by the various authors, that Britishers had learned this thing from India as they were ruling this place, and they might have replicated that this thing in their place in 1738 kind of thing, because this zinc production was continuing even till Britishers landed in this place, or maybe after that. And let us look at location of the zinc deposit in India, and these are the places lead and zinc deposits are there. If you look at, this is the Java region where the lead mines of course there, and 25 kilometer from that these are all places, Deri, Amba Mata, and there are several places. Of course, the other places are there here in other parts of the country. The rock in this region is Aravalli region, right, Aravalli mountain range. The rocks in Aravalli range in the southern Jawar are rich in zinc ore in the form of sphalerite and galena. These two ores we had discussed earlier, with varying quantities of pyrites in the form of seated zones, and there might be veins and stringers, of course, the lenticular bodies kind of things that where the zinc will be there in between. And since these material are quite distinct from each other, it might be possible at that time to separate them manually, and that is the reason why zinc mining and smelting was developed at Jawahar region, this region, right, that what people are anticipating. And 7 distillation furnace of almost square shape, we will see its image like having a dimension like this is the 69 centimeter and this is 60 centimeter, were discovered this Zawarmela hill region, and these are the earthen retort place where it will be placed, and there is also the perforated these are also some holes are there here in this region where being made for the air passage and also the ash to be coming down to the furnace. We will be discussing more about it. And the production of metallic zinc by distillation process was started at Jawahar for the first time in the world as claimed by various people. Beside coins, several other brass antiquities, namely leads, caskettes, bangles, finger rings, utensils, icon, chariots, religious objects, utensils have also been found from early historic site in Uttar Pradesh, Madhya Pradesh, Gujarat. Several brass images of Buddha were discovered from Popnakala of Barnapur district of MP and East Nimad district of MP, belong to Gupta and Bhataka period, something around 500 to 600 CE. Huensang, a Chinese scholar of Buddhism, around 629 to 445 CE, mentioned about Buddha statue in a magnificent vihara near Nalanda during the reign of Harshavardhana 606 to 647 CE. And this statue is made of brass, as it was mentioned in his travel log. A large number of ancient bronze belonging to Pala, Sena and Kalinga school of art, around something 800 to 1200 CE, contains considerable amount of zinc, which were found in the eastern part of ancient India, including region of Bihar, Odisha, West Bengal and Bangladesh. And moreover, records confirm that even until 1840, the tribal people of Jawar were using the distillation process for production of pure zinc, and that clearly indicates that Britishers might have learned this thing from the tribal people of Jawar region about the distillation process of zinc smelting. And this is about, of course, archaeological evidence, but there are several literary evidence of the zinc in ancient India. One can think of Susur Samhita and Charaka Samhita, which have clearly mentioned the use of essence of different minerals and metals such as gold, silver, copper, tin, bronze and brass for preparing the medicines. Of course, we have discussed some of them, but we are now talking about brass, which contains zinc, and both these texts mention the brass as a riti or ritika, and also they refer this to the Puspanjan, which was prepared by heating a metal in air and was used for curing eyes and wounds. That means, this brass can be done that job. And brass was also frequently mentioned in ancient Sanskrit literature as riti or ritika. The word probably derived from the harita or yellow color, because of brass being yellow in color. The term Kamsakuta or Diganayaka or Dharmapada of Ashtataka was interpreted as a brass coin. Beside this, writing of Manu, Yajnavalkya and Patanjali of the pre-Christian era also referred to the bronze as a kansya and brass as ritika. And Kautilya Arthasastra also among one of the earliest textual evidence for mining and smelting of metal in ancient India. In the Arthasastra, brass has been mentioned as arkuta and liquid ore. According to the Govila Griha Sutra, the Vedic students were supposed to dip their hands in vessel made of brass and alloy of copper and zinc. Rasaratnakar by Nagarjuna described the method of production of zinc, and if you look at about their dates when it was, there is a little controversy, but however, one can see very clearly in that book that it has described about a cementation process of making zinc. And in this cementation process, the finely divided copper fragments were intimately mixed with the roasted zinc ore and reducing agents such as charcoal, and heated up to the temperature around 1000 degrees Celsius in a sealed crucible, and the zinc vapor formed dissolved into the copper fragments, yielding a poor quality brass. And unfortunately, by this method the zinc percentage can be easily controlled, but they produce this brass in a small quantities because for the medicinal purposes. and object containing more than 28% zinc are called real brasses, are made by cementation process, as well as the distillation technique of zinc production for the first time. Beside this, there are several alchemical texts has mentioned about the use of brass and zinc, and these texts also mention about different kinds of zinc ores such as Mritika Sarasa, Guda Rasaka and Pasara Rasaka. And Rasakalpa and Rasaprakasha Sudhakar of Yasodhara, Rasendra Chudamani of the Somadeva, Rasa Chintamani of Madanta Deva are being written around something 10 to 12 centuries AD, explains various types of brass and zinc making by distillation process. And these texts reveal the fact that Kosti type of furnace were used for smelting, and the text also mentioned that furnace consists of two chambers separated by perforated plate, and Triyanka Patana yantra were used for distillation. If you look at, there is a lot of literary evidence for zinc distillation technique and also the cementation process for making zinc. Let us look at what is the basic principle being used for smelting the zinc in ancient time, and generally it is being produced by the sophisticated distillation process, which comprise of mining of zinc ore and smelting of ore and of course, the final product. Various archaeological and literary evidence what we have seen just now suggests that both the open cast and underground mining were being practiced by the ancient Indian at various places for obtaining the zinc ore. And this is the diagram which I am showing, particularly a distillation process. If you look at, this is the container where you can take a liquid and heat it, the vapor will be formed, and then you will take this vapor out in this tube and you cool with the help of water or air cooling, so that it will be condensed back. And this process is basically being used for zinc productions. That means, the zinc ore is taken here and then it will be heated with the help of course, the flame produced by due to the burning of wood, and of course, I mean which is shown here, but in actual situation the charcoal is being used in that retort, that it will be the zinc will be vaporized and then it will be passed through this tires or the pipe, which will be can be condensed by with the help of cooling it, and also vapor being air cooled here in this pipe if it is made of metal. So, let us look at that smelting process and production of zinc in ancient India, and as I had mentioned earlier, there are few metals which are produced by the downdraft reduction distillation technique, and zinc is one of them because of its boiling point is very low. And what is being done in this case is that the charge is prepared. Of course, for preparing charge, that ore has to be crushed, grinded and to the proper size, and beneficiation will be taken place, and then you will have to mix these things calamine or the zinc ore with the charcoal, and then you will be putting into a crucible and covered it and heat it maybe around 1000 degrees Celsius. As I had told you earlier, that zinc sulphide and lead sulphide, sometimes they together, these sulphide minerals are converted into their oxides, right. And once this oxide, zinc oxide is being produced, then you will have to separate it out, and then this zinc oxide mixing will be again the charge will be produced, will be prepared by mixing this zinc oxide with the charcoal powder, of course, the wood charcoal, and then salt, borax and then you will have to use the cow dung and water so that it will be binded properly, and then you will have to make some kind of a pellets of ball size around 5 to 10 mm, and these pellets are to be sun dried, and these ball set pellets are being put into a retorts of length around 20 to 35 centimeter, diameter 8 to 12 centimeter. Of course, is volume, two volumes were being used in ancient time, one is 750 cc, other was a little larger or later more than double, that is 2000 cc. And then of course, one it will be placed, and then it will be actually put into the smelting furnace, which I will be showing detail, which is of a truncated pyramid shape, and then it will be heated to a little higher temperature. As a result, that zinc oxide will be reacting with the CO, which is produced by this charcoal, right, and then zinc will be produced and also the carbon dioxide, and it will be in the vapor state zinc, and then you will have to condense it to get the zinc metal. So, this is the what you call vertical section of a zinc reduction distillation furnace, which was obtained at Jawahar Mal, and this if you look at it is basically a truncated pyramid shape, and this height is 60 centimeters. If you look at this from here to this thing is 60 centimeters, and these are the earthen retorts which are placed in this, and this will be the sectional view. If you take, it will be shown here, this perforated thick plate of bricks, right, and which will be holding these earthen retorts, and in this place these are the earthen retorts, and these are the small holes which will be there to for the air to pass through. And as I told that this is a furnace is having 69 centimeter, this is basically 69 centimeter, and this is your 66 centimeter cross section. And the charge in retorts were heated around, as I told, 1200 to 1300 degrees Celsius for a duration about 3 to 5 hours. And retorts have the length of around 20 to 35 centimeter and diameter of course 8 to 12 centimeter kind of things. And generally what happened, like here the fuel being placed and it will be burnt, so that heat will be soaked into this region. And then this of course there is a lower chamber, the peg is there which is being what we call support this brick, and there is a container which has been displaced little bit, and this container is being placed where once this is being melted, vapor being produced, and then it will be coming out. Let me show you the retort, and this retort will be containing a small pellets of spherical size and together, and it will be packed in this brinjal shape retort, and with a wooden stick in between, this wooden stick, right, this is your wooden stick, and which will help to support this thing so that it will not fall due to gravity. But another interesting that once it is heated to the 600 or around degrees, this will be also having some carbon and giving the reducing agent and some carbon dioxide formed, and also it will create a passage for the vapor to come out and collect in this vessel, right, lower chamber vessel. And as I told, the borax and added salt must have been helped in low temperature sintering of charge and slag, that will be, and cooling of gas leading to the sudden volume expansion lowering the vapor temperature, and the chilling action of air draft in the bottom chamber might have occurred due to this sudden volume expansion kind of things. As a result, and this through these passages, like your ash and other things will be coming, and also the some air will be moving into that what we call air for the combustion of this fuel, which will be in this place. So, this is a beautiful system what they had devised for producing zinc out of the metal. And let me conclude that zinc was no more a rare metal for ancient Indian metallurgists, as the oldest evidence of pure zinc comes from India only. It has been accepted by the researcher, and the credit for bringing about breakthrough in non-ferrous metal extraction first in the world undoubtedly goes to the ancient Indian metallurgist. They devised an indigenous method for downward distillation of zinc vapor to produce pure zinc, and various gadgets of zinc on a commercial scale. And from India, the technique of zinc extraction might have spread all over the world through trade and communication, also by traveler coming to India from time to time. Of course, this is a very clear evidence which had been discussed earlier, that Britishers might have learned from us what they produce in Bristol. And therefore, it can be concluded without any doubt India is the oldest commercial center of the world for zinc production. And thank you very much for listening this talk, and then we will be discussing more about how to make a what we call bronze idols out of this metal in the next lecture. Thank you very much.